Hello students, now we are going to start with the next part of our biomolecules chapter, that is a part of proteins and amino acids. So let's start with a basic introduction. Firstly, what are proteins? Proteins are nothing but naturally occurring complex nitrogen containing polymeric compounds of higher molecular weights which on hydrolysis gives alpha amino acids or amino acids. So, proteins also consist of elements like carbon, hydrogen, oxygen, nitrogen and sulfur, and along with this there are certain proteins which consist of cobalt, magnesium, zinc, iron and copper. So now what we have learned according to the definition is proteins on hydrolysis gives a mixture of alpha amino acid. Now students, here the name itself tells us the structure. We require two groups, that is amino and acid group. So let's take a carbon atom to which I have binded an amino group, I have binded an acid group. Suppose now the same carbon atom was binded with H and hydrogen to satisfy the valencies. Then we would get a compound that would be nothing but our amino acid, also referred as alpha amino acid. But now in this case NH2 is onto the left hand side, so this would be referred as L amino acid. Similarly, if we once again take a central carbon atom, attach it with NH2 and COOH, again for satisfying the valency we put hydrogen and any alkyl group. This would again be an alpha amino acid, but now NH2 is onto the right hand side, so this would be called as an D alpha amino acid. Let's move further and now let's understand some basic structures of amino acid. We have an amino acid which is something like this. So let's take an amino acid, but now in this amino acid I am removing the R and instead of it I am adding an H. I would get a compound or an amino acid called as glycine, represented as GLY. Moving further, again let's take an amino acid, but now instead of R we would put something else. Let's suppose CH3. Then we get a compound called as alanine, written down as ALA. Moving further, one more where R is now removed and instead of it we are adding a group that is CH3 twice. I would get an amino acid called as valine, represented as VAL. Next, if R group is now removed and placed or written down something like this, CH2, CH3 twice, I get an amino acid called as leucine, written down or symbol is LEU. Let's move further. Let's take one more amino acid. Again the R is removed. Instead of this we place CH3, CH2, CH, CH3. We get isoleucine. Next, if we take once again R, remove the R, instead of it place a group like CH2, CH2 thrice NH2. We get a compound called as lysine. Next, instead of R, removing R, placing a group that is CH2, CH2, COOH. We get a compound called as glutamic acid. Next, we are adding R, but now this R would be nothing but CH2SH, a very important amino acid called as cysteine. And lastly, what if I have an amino acid in which R is removed and instead of it we place CH2 with a phenyl group? Then we get a compound called as phenylalanine. So these were some basic amino acids. Let's now understand what are amino acids derived from. Then it is said that amino acids are derived from carboxylic acids by replacing their alpha hydrogen atoms. Let's see how. Let's take in carboxylic acid. Suppose we take acetic acid. Now, what we are doing is, instead of writing CH3, we are writing the same CH3 in this fashion. We are taking one alpha carbon to which there is an alpha hydrogen which is attached. Now, our aim is removing this alpha hydrogen and instead of it putting an amino group. So what would happen if I place an amino group over here? I get a compound that is nothing but my amino acid. But now, remember students, here we have 2H which is attached to the alpha carbon. In this case, suppose if H is equal to R and H is not equal to R. If H is equal to R, then the compound would be optically inactive. Whereas if H is not equal to R, then it would be optically active. Let's see how. If I remove H and instead of this place any alkyl group, then what I would get? I would get a carbon that is optically active. Why? Because it would be a chiral carbon and thus the entire compound is optically active compound. Now, what we need to know over here are some important points for proteins. The first point, all proteins or our amino acids are optically active except glycine where H is equal to R. Next point, hydrolysis of protein gives 30 amino acids out of which 20 are essential for human body. And lastly, all the proteins are named based on either their sources or their properties. Let's see an example for this. Then, name glycine gets derived from glycos, meaning sweet, whereas tyrosine is derived from the word tyros, meaning cheese. This was all about the introduction of proteins. Meet you in the next module. Till then, thank you students.